All right, welcome to another wonderful webinar from the Utility Broadband Alliance. We are all about knowledge sharing here, and we have the opportunity to learn some more today. So I want to welcome everybody to the webinar, and on behalf of UBBA, thanks Ceragon Networks for being our host for today. I also want to remind everybody that we do like interaction on our webinars. So there is a question tool and part of your toolbox there. You'll be able to type in your questions just as you have them. At the end, we will save some time to be able to answer your questions. Of course, we'll do our best to get to all of your questions. If we don't and we run out of time, then of course we'll follow up with you individually after the call. But for now, I just want to remind you to please use that question tool and to make this very interactive. We are recording, so of course we'll post the on-demand version of this later, but now is your chance to engage with our speakers. And without any other moments, I think everything's getting loaded in, so I want to quickly save the time for our wonderful speakers, Dimitri and Shimon from Ceragon Networks. And Dimitri, I'm going to turn it straight to you, sir, and let you really kick us off and take us down this quite important and quite technical topic. So I'm looking forward to learning today.
Appreciate that very much, Bobby. For everybody on the call, my name is Dimitri Batistas. I am the sales manager for private networks, specifically in the utility vertical for North America on the private network side here at Ceragon Networks. I've been with the company for about 3 years at this particular point, but I do have extensive knowledge in wireless system integration for the last 10 years, as I've been working previously in Canada for wireless system integrators, looking at different various technologies with an expertise actually in microwave backhaul. Shimon, would you like to give a quick introduction?
Yes, thank you, Dimitri. Hello, everybody. My name is Shimon Hochbaum. I'm working for Ceragon Networks now. Came through with the acquisition of Siklu. In total, I'm 10 years now in this wireless networking solution business out of HQ in Tel Aviv.
Perfect. Thank you for that. So we heard Ceragon Networks. Just a brief two slides on who Ceragon Networks is. We're actually a global innovator and leading provider of carrier-grade wireless network solutions. We do focus in 5G wireless transport, private LTE, fixed wireless, microwave, and fully managed solutions. Our main book of business within the last, I want to say, 20-something years was the tier 1 operators. And essentially 4 years ago, we actually created a business unit called Private Networks, where we're serving the rest of the world, more in the space of critical infrastructure, including utilities, public safety, defense, transportation, oil and gas, and energy. So we are a global company based out of Tel Aviv, is our head office. We are actually publicly traded on NASDAQ, so you could always go and check out our CRNT on the NASDAQ. And essentially, just a little bit of a snapshot, we've been in business for over 27 years. And in 2023, we actually managed to generate $372 million of revenue. And with that said, this is a company snapshot. So we do have presence in Europe, Africa, North America, India, APAC, and obviously Latam. Some of our larger customers are the T-Mobiles of the world, the Claros, Dish, Vodacom. But one thing I do want to say is that we have quite a bit of customers all around the world. We have a lot of experience with systems deployed, and essentially, we're over 1,000 employees globally. So we're here to basically meet all of your needs. Now, to the topic at hand. This is something I'm actually very excited about. It's basically lights, camera, and action. Basically, how utilities are protecting people, places, and assets. Now, I do have to put a little bit of a caveat here. So the presentation is lights, camera, action, but we're actually going to be working in reverse. And there's a method to the madness. And one of the reasons being is, for the agenda, we're going to be looking at the action. What are some of the investments? where is the funding coming from, how to understand the landscape. The camera portion will be more on the security aspect, the physical security aspect. As we all know, there's a very big push on the physical security for critical infrastructure in North America, making sure that we do protect not only just the assets and the places, but also the people that are working within them. And then essentially lights, which is going to be a little bit of a surprise, where we're looking at thinking outside of the box in terms of network resiliency and just adding a different layer or an additional layer within the network itself to basically bring this all together. So action, we got to understand the landscape. There are major investments benefiting utilities. The U.S. government has been investing heavily within the utility markets, as we've seen within the last 2 years. The DOE, Department of Energy, is investing $70 million for research aimed at enhancing security, resiliency, and reliability of systems. Usually they're looking at specifically the universities, in partnership with the universities, which Ceragon Networks has been very proactive in that particular front as well, looking at the next generation of utility workers, looking at the different technologies and just the different ways that we could set up resilient networks that is basically an evolution from the traditional way of doing things. There's also a PACE program, which is the Powering Affordable Clean Energy, which announced about $960 million of funding last year. That program is basically to provide loans and loan guarantees to energy project developers, specifically for distributed energy projects, including renewables that provide wholesale or retail electricity to the existing programs. There's also the Denali Commission, basically high energy cost grants, which is lowering the cost of energy for families in low income housing or low income areas, I should say. And essentially they're looking at making sure that the utility costs are not going to increase substantially within the next few years at this particular point. And that's where the intervention comes in. Just looking at basically an overview for smart grid and broadband funding. I mean, we do have the USDA, which is the Rural Utility Service, or RUS programs that are actually looking at loans for smart grid upgrades and rural broadband. The Electric Infrastructure Loan and Loan Guarantee Program, which is supporting rural electric utilities in building or upgrading electrical infrastructure, including smart grid technologies. So, when we're talking about smart grid technologies, as everybody knows, we're looking at distribution automation, we're looking at smart meters, we're looking at communications infrastructure as a whole. And this is basically direct funding for broadband build out in areas that are lacking, insufficient access. And a lot of the applicants are that RECs, telecom co-ops, but where we want to concentrate is actually the public utilities. So this is something that we could definitely assist, or that a lot of the utilities on the call should be looking at when looking at their, upgrading of the critical infrastructure or their smart grids at this particular point in time. Department of Energy as well, grid modernization and infrastructure. They're supporting grid resilience and digital modernization, basically through grants, partnerships, and state collaborations. The GRIP program, or Grid Resilience and Innovation Partnerships program, is basically funding about $10.5 billion. And this is basically to enhance grid resilience through smart grid technologies, storage, microgrids, infrastructure digitalization. And then there's also the Smart Grid Investment Grant as well, which is ARRA funded, basically from 2009 to 2015, but they've actually extended that. And that's mainly for the advanced metering infrastructure. Now, we all do know that AMI 2.0 is coming back or coming into play as well. There's a lot of testing within the utilities, which is very exciting, but we also know that it is a little more bandwidth hungry compared to the rest, or the first generation, I should say. So these are some of the examples of what's out there in terms of funding, specifically for the utility market. And we do see a trend for the grid modernization and the infrastructure that they're really looking to bolster up. And of course, we got the NTIA broadband infrastructure program. This one's quite interesting. And basically this can indirectly support utilities, more likely for the electric co-ops, if you will. So as you know, this broadband equity access and deployment, which they call the BEAD program, includes a lot of utilities, RECs. Public utilities are eligible as well to receive funding for this. And then there's also the middle mile broadband infrastructure program that they offer, which, they're talking about building the fiber backbone, connecting local ISP and utilities. Although from what we've seen, there's been a little bit of a shift as well. It's not heavily fiber focused. They're actually looking at capital projects at this point that are basically looking at various technologies as well, not just fiber itself. So what are some of the utility challenges? I mean, we all know that there's aging infrastructure out there. I've seen it quite a bit. I mean, just looking at the FCC data and a lot of the infrastructure that, having conversations with a lot of the CIOs, CTOs within the utilities, it's difficult to support various technologies. If we're looking at sensors, advanced video applications, and AI-powered software, from what we've seen in the last 10 years, there's been a massive evolution towards the edge devices and applications, whereas the infrastructure wasn't basically able to keep up, because traditionally in infrastructure, you're looking at minimum 15 to 20 years before essentially, going through that evolution path. Whereas now it's been sped up because a lot of these edge devices or these new age next generation applications are actually asking for quite a bit of bandwidth capacity and basically criteria in order to be met. Cybersecurity is another one. There's an increase of cyber attacks threatening both IT and OT operations. Anytime you open up the news, we all see the headlines on ransomware, on basically critical infrastructure being attacked via cyber attacks. And of course, also another aspect is physical security, and that's something I definitely want to hone in on today. Basically, that pose a risk, and essentially you're looking at critical infrastructure that could be damaged to the point where it is a question of national security. So on the physical security side, we want to talk about sensors and detectors, next generation video surveillance, analytics and AI, alarm systems, integrated response systems, and of course, putting together resilient communication networks. This is basically a topic that we could spend hours, if not days on, but I really want to hone in on some of the next gen video surveillance applications where you have thermal imaging included. You do have sensors for movement, for proximity. Even if we're talking about asset protection in terms of extreme weather, if we're looking at smoke detectors, if we're looking at temperature detectors. I know that last year there was quite a few natural disasters that hit North America, specifically in the US and even in Canada, that impacted a lot of the utilities, especially on substations, generation stations, and then essentially, obviously, physical attacks. So, putting together an ironclad system where you have thermal imaging, you do have sensors, you might have workers with PPE equipment that basically need connectivity. And then on the back end, having that analytics and that artificial intelligence to put it all together and essentially have some type of preventative model to basically secure and protect people and assets as well, while integrating that into a integrated alarm system where they, essentially get some of the other agencies involved if need be for an integrated response, and making sure that when you're putting a wireless network together, it's not just the end user devices or the applications, but it's really putting together an ironclad resilient communications network where there's not a single point of failure. There's a difference between resiliency and redundancy. For myself and here at Ceragon, where we're putting together a wireless network specifically on the critical infrastructure side, resiliency is key, security is key, and obviously availability, but the resiliency, when we're looking at not having a single point of failure, there's a little bit of slack and there's a little bit of essentially a peace of mind when dealing with either a physical attack or some type of natural disaster, and making sure that operations are continuing. So let's talk about cameras. We do have a couple of use cases. When we're talking about physical security, video surveillance is probably the hottest topic right now. We've done some projects all around the world, but I want to specifically look at two use cases that we have here in North America, and essentially how we guided them through that journey of putting together number one, a resilient wireless communications network that basically supported their next generation camera systems within that particular area itself. And with this, I'll hand it over to Shimon. Shimon, are you ready to talk a little bit about some of the nuclear power plant stations that we worked on?
Yes, thank you, Dimitri. So here we have a very unique situation where power stations are well known as being very important to protect and to operate securely. And there was a mandate a few years ago to upgrade the perimeter security with a lot of technologies that actually we don't understand a whole lot, but the end result is an early warning alarm system. And how do you deploy all these sensors, cameras, and a lot of advanced technology built into these cameras and around these cameras, and backhaul all this information to a place where they can be analyzed, processed, and acted upon. So the challenge here is to deploy a network in a working environment. Nobody was planning to stop operation of these stations, and fiber was not available to begin with. And how do you backhaul all this securely, efficiently, and reliably? So the people in charge of this project turned to back then Ciclu, now Ciclu by Ceragon, and we have this very interesting technology which allows us to run gigabit capacity wireless networks around and through the plant, where normally somebody would have said, well, we need to dig some fiber under or through the plant. Not possible when the plant is working. You can think about many reasons. Here we are just the wireless guys. We don't understand all of them. But we could deploy a redundant, highly reliable wireless network with no single point of failure, self-powered, because power was also not available all around the perimeters and at some of the locations where sensors were required. And the end result is a multi-gigabit network going around and through the station, supporting all of the technology that was required, approved by NRC, which allowed one of the top 3 operators in the nation to, after passing approval at one station, to go and deploy across all of their stations. It's something which proves the reliability of what can be achieved with wireless technology, where fiber could have been maybe desired, but was not an option to begin with, and able to deliver the same reliability, the same latency, the same capacity as fiber without all of the hassles and challenges of deploying fiber.
Shimon, would you like to maybe touch upon the system is secure from jamming and fully air-gapped?
Yes, so it's air-gapped because it's basically a reliable network which is standalone. It's not connected to any public, no mobile or fixed network. So there is no ability to enter or penetrate this part of the solution. It's redundant, resilient. There is more than one pathway, if you want, to any of the locations, sensors, and whatever is connected on this network. making it also reliable so that there is no single point of failure. And from a wireless technology, it operates in a portion of the spectrum which is very unique. It's the 60 gigahertz V-band, which is unlicensed, so it allows anybody to deploy that technology without purchasing spectrum or paying for operation of the spectrum. You don't have to pay for SIMs or any of those. However, because of the 60 gigahertz properties, you can operate links which are 1 gigabit, 2 gigabit, maybe even more, at distances which are more than enough to go around the perimeter of the station or through the station, with beams which are what we call pencil thin beams, virtually undetectable, practically not possible to interfere or to jam. So here is a little bit of what an implementation could look like. The implementation in every station will be a little bit different, but we see here the concepts of how it is deployed. You can see rings which are independent of each other, so that there is no single point of failure. Every ring has more than one direction, so that there is per each ring, again, no single point of failure again. The wireless technology is low power, something which can be easily solar powered together with the power requirement for the sensors. So all of that is something which is not very difficult to deploy for many of the partners, integrators that you guys may have out there. Training is done, literally hours for most of the design activities, deployment, installation activities that they would need. And at the end of the day, we get something which is very unique because it's just as reliable and same capacity, same latencies as fiber. But think about if you really want to have a highly reliable solution, you need to go through the station, no matter what these areas truly represent. And again, if it's a working station, it doesn't matter what the station does, if it's nuclear or otherwise, virtually nobody will allow going through the station with fiber, and you can probably know better than me why it's not allowed.
Yeah, and just as a little point added, we've also done networks where we've actually gone to 3 wireless rings, just because of the sensitivity of the asset that basically we're trying to protect at this point.
Yes, the number of rings from a density point of view, often people are confused because with fiber, with Wi-Fi, it's very well known that as soon as you have too many radios in proximity, they begin to interfere with each other, and you spend a lot of time trying to get it right, which you don't really can with traditional Wi-Fi technology. Here you have something which is operating in a very different portion of the spectrum. If you think about your traditional Wi-Fi is 2.4, 5, now 6 gigahertz. We begin somewhere at 60, which is like 10 times further along the way in the spectrum, what is called millimeter wave, because the wavelength is in the order of a millimeter or two, and that makes a lot of the resiliency of these signals to be so, because they don't propagate very far. We see that the link distances are not very long, and that's why it's very practically interference-free and not possible to jam. A lot of people have tried before we could get approval from NRC, and the end result is an approval of that technology. Here we have another utility. So in this case, we are allowed to say where. It's in Hawaii, where they needed to deploy also a lot of more traditional video cameras. Back then, supplied by Axis, and they needed to backhaul again their cameras to where the pictures are required, where processing happens, where eyes can react to what's happening. So there too, a lot of Etherroll and multi-hole cameras were deployed. Etherroll are point-to-point cameras, multi-hole are point-to-multipoint. There comes the brand and multi-hole from, and allows to create different types of topologies to address in a more efficient way the needs of the utility or the plant topology or whatever we need to do there to be efficient, to be able to deploy quickly and address the key parameters of the location. We have also some technology which operates even higher in the spectrum, which is the Etherroll 70, 80 gigahertz. So we spoke about 2.45, which is the traditional Wi-Fi bands. Now we are, we say we are 60 gigahertz for the previous case, and here for initially what we were doing with Hawaii Electric Company. But then they discovered that needed to connect some remote locations or between locations, and now we need to have links which are measured in 2, 3, 4, 5, actually 15 kilometers sometime. So we go higher in the spectrum, we can go further, longer distances, capacities which are measured in the 10 and 20 gigabit. So really comparable to fiber in all respects. Sorry, if you can go back, one thing which is interesting, which was really the trigger here now that I remember, because it's a traditional station, there is a lot of vibration. And actually that plant was deployed originally with fiber, but the vibration around the ground and through caused the fiber to deteriorate. Now you could say, okay, let's replace it, and every 5 years we'll do a replacement again. That's not very efficient for a number of reasons. That's not always secure because you don't really know when the fiber is going to break. So that was another good reason to look at other technologies which are, I would say, vibration insensitive, for lack of a better word, and another trigger to the deployment of wireless technology around and inside and through the stations, where you have to combat these kinds of mechanical issues in that case.
Yeah, and I'd like to add something as well, Shimon. Having many conversations, at least with third-party vendors and other utilities, there's a very big push, first and foremost, obviously on the infrastructure, but because of these high-capacity radios that are able to provide a lot of bandwidth or capacity for these cameras, it's advantageous just because it is essentially ready for the next generation applications. Like for instance, having a conversation in the market, there's a lot of utilities and even on the public safety side where they're using these cameras essentially to secure particular locations. So for instance, if there is some type of intelligence on the background where this camera could scan, for instance, a vehicle that's approaching this quote unquote location, they're able to have a license plate detector. And with that detector, they're able to authorize, is this, or validate, is this an authorized vehicle? Is this not an authorized vehicle? And all depending on where exactly they set it up within that particular location, they're able to mitigate any escalation, if you will, and basically intercept that particular vehicle. If it's not authorized or part of the quote unquote fleet, they're able to intercept it at a much further location than where the actual asset is. And they could even tie it into the access control portion. They could even start integrating a lot of the PPE equipment. So that's something interesting as well when we're talking about next generation applications and basically setting up the backbone for that.
Yes, and what we all know is that one thing is clear in our world, the bandwidth always goes up. We've never seen the bandwidth go down. yes, a lot of smarts are always added to the edge and the sensors, and but cameras, sensors are have gone from hundreds of pixels to multi-megapixels, 360 degrees, which require more sensors or very slow latency, because now you rely on the PTZ camera, and you wanted to respond very quickly to the joysticks and move and be able to track whatever you want to track on the ground or in the air. So all that calls for more and more boundaries, slower and faster latency, which Wi-Fi is long forgotten, the kind of performance that is required here. Literally fiber in the air, that's what we bring. We are not saying forget about fiber. It's not that would not be right. We love fiber because we know that wherever you deploy fiber, at some point in time, you will run out of some reason to be able to deploy the fiber, whether it's going to be a broken conduit, vibration, as we could see here in this story, or just the need to deploy it, as fast as possible. And we all know that fiber deployments never happen quickly, never happen smoothly. If you want to stay in budget, on time, one sure way to do it is going wireless. But again, not Wi-Fi, because of all the issues associated with Wi-Fi, very ease of jamming and taking it down and whatnot, or just interference from somebody coming by and not knowing that they are causing a problem to somebody else. We have again no limits in campus applications with the hundreds of links deployed, and nobody ever complained about the problem, and we know why. But we have a well-loved city in California, San Francisco, which has been the hotbed for millimeter wave communications for probably as long as Ciclo exists now. And if one looks at the count of millimeter wave links deployed in the city, courtesy of the mandatory registration with the FCC when operating in the 70, 80 gigahertz bands, but not in the 60 gigahertz, if anybody's concerned. So literally you can see thousands of links deployed all across the city, operated by many different organizations, different vendors. Good majority of those are Ciclo, but no, Ciclo now, Ciclo and Ceragon, but not the only vendor. By all means, there are others. And again, nobody has ever complained about interference anywhere in San Francisco. That's probably the densest deployment that we have. Again, thousands of links all across the city, from roof to the street, from street to the roof, along the streets, between roofs, and nobody ever complained. And we are quite certain that it will remain so. We are already looking at going higher up in the spectrum to the 90 gigahertz, 140 gigahertz, to guarantee that there won't ever be a lack of channels, no interference, and just making it more and more capacity available wherever and whenever that's going to be required.
Which brings us to the last portion, which is lights. This is a broadband luminaire. This is something that we're very excited about. It was essentially a dream or a thought that was pitched out that came to fruition, just because we want to think outside of the box, specifically with a couple of customers that we really think could basically leverage for a lot of the utilities, can basically leverage for quite a few applications, and really putting in that redundant / resilient network together, whether it be a small deployment or a very large deployment, especially on the publicly owned utilities. Broadband luminaire is basically, we're converting the light infrastructure into a mesh backhaul for quite a few applications. And Shimon is actually probably our product specialist on this one here. Shimon, do you want me to go through this entire slide, just one by one?
The story is very simple. If you think about public landscape, and you think, where are people, where are cars, where are vehicles, where are all the assets that I want to protect? Guess what? They are just across from a luminaire. So Wherever there's people, most of the time there's going to be a light grid. And when we were looking at where people are putting all kinds of assets, cameras, Wi-Fi APs, small cells, IoT sensors nowadays, and whatnot, typically it's all hanging on a luminaire somewhere. And so it's become very natural for us to think, what if we could help all these deployments, rather than waiting for the fiber to come through. And again, you can think about any number of cities where getting a permit and being able to bring fiber is going to take a year to two, but in many places it will just never happen because it's a historical area. There is maybe some public transportation, a rail or tram or just a waterway. Many things which just say basically forget about getting fiber ever through this 20 meters maybe or more. So it's just a natural thing of thinking, okay, let's utilize these luminars and let's enable them to be the grid, the communication grid, not just the lighting grid of the city. And so we worked with some good partners to basically transform a traditional lighting-only luminaire to be a broadband luminaire with integrated wireless communication, same kind of technology that we have in standalone products, basically built inside the luminaire. You just go and replace the luminaires where you need to backhaul some assets, where maybe the fiber is available, and sometimes if the distance is not right, you put a few more luminaires in between, and you let it all activate itself and basically create, and if you can just continue clicking on your mouse, please, Dimitri, and basically you create a wireless mesh across the city where just about any asset which needs to be backhauled is just like a plug away from getting from point A to point B very easily. That's all the magic. And we see quite a lot of interest because the end result, and I think we have more slides about this, correct? It's something which is very discreet. So yes, you want people to see the cameras, you want maybe people to see Wi-Fi APs, or because you want to bring them on the public network or you want them to feel secure and protected, or watched over, and don't do anything to this location because we've got you on camera and we'll come after you if you do anything stupid. So these assets, in general, you want them to be visible. On the other hand, the network, you don't necessarily want it to be visible, and there are many reasons, because people sometimes may object, because just putting more hardware than necessary on the pole is going to make it not as nice looking. Sometimes, again, there are people who pay a lot of attention to the visual aspect of these light poles all over the city. There are all kinds of requirements. The mayor sometimes has a preference for a certain color, certain size, or the council in general, and they decided that's how we are going to do the city, or that's how we are going to do this specific street for very special reasons. And again, just as you were not allowed to do fiber through this neighborhood, now you are not allowed to put wireless tech across the neighborhood. But if you can integrate the wireless technology inside the luminaires, whether the traditional gas light looking luminaire or the very modern flat copper head, doesn't matter. We can put these radio technologies just about any form factor that is required, so that we have created this wireless mesh with nobody paying attention to it. It's not visually seen. The installation, just like you have your your Department of Public Works, DPW, being able to replace luminaires because you want to migrate from traditional to LED technology on the lighting front, just because from time to time the lighting breaks and need to be replaced. So the same guys who know how to replace the luminaire they know how to upgrade the luminaire from traditional to broadband. It's just the same, take the luminaire head out, put a new luminaire back in. They don't need to know anything about technology, about wireless, about networking, about configuration. For them, a luminaire is a luminaire, will be a luminaire forever, and that's all they need to do. So it's unobtrusive, you don't see it. It's very quick to deploy, 2 screws, 20 minutes on the board, and just like you replace a luminaire, you upgrade it to broadband as well, and then it will self-organize. You have a network across the city. From a network architecture point of view, just in case I was not clear initially, so you have all your broadband luminaires. Again, not 100% of the lighting luminaires which are in the city need to be upgraded. Somebody is concerned about the numbers. We probably will replace 1 every 5, 1 every 10, depending on the application and the distances between the luminaires. So you certainly don't need to upgrade, and you only upgrade them where networking is required. One of them or more will be connected to the fiber network available somewhere in the area. In case there is no fiber network, because it's interoperable with our traditional wireless technology, then we will backhaul from the street level to one of the roofs. And from there, we know how to do the job. And at the other end of this mesh wireless network, then you can connect all kinds of assets. Maybe you have a library which has very poor internet connection, and you want to ensure just good internet access to that library. Maybe you have a business which is complaining that the incumbent is not delivering on what they committed, and because it's a good partner for the city, you want to help them. But most of the case is going to be about enabling again, your CCTV applications, your IoT sensors. Maybe you want to run a public Wi-Fi network, in the pedestrian areas of the city, to ensure that everybody is covered wherever they go. Maybe you want to close digital divide in some other places around schools, the less favored areas of the city, where again your traditional wireless incumbent or wired incumbent don't want to spend their dollars for all kinds of bad reasons, but here you can come and address this part as well. A lot of applications can be run in parallel on this technology. So just like we were seeing in the case of protecting nuclear and other stations, with all of the networking applications that we need to run across and around the station, here too you probably have the need for multiple applications. You can run multiple applications because you have the capacity to do so on this wireless mesh, and we have a lot of other security measures which allow to separate between, for example, your CCTV camera can be on one logical network, completely separated from the public Wi-Fi. Now, if somebody will think that there is any risk from one to go after the other, the wireless mesh, even though they share some of the radio links, we can still run in isolated logical network, so that there is protection or maybe better quality of service to some of the applications that you care more than others.
And it also ties back to the first section, which was action, where this is dual use, and essentially for a lot of these applications and these grants, basically leveraging multiple use within, for instance, these subsidies, whether it be in a highly densely populated area or sometimes in a remote area, getting this connectivity, whether it be partnership with the municipality and the local utility or vice versa. This is a prime example of that, because essentially it is bolstering up the infrastructure and the resiliency of the quote unquote grid itself, right?
Yes, and we have some partners that we have helped understand what kind of fundings and how to navigate through the funding vehicles, in case if anybody is interested.
Correct. And they're also, broadband luminaires, they are recognized for national, regional funds and grants as well. And that's something we could definitely assist. finding the money is one thing, getting it is another. But we've put together quite a bit of ironclad ecosystem to assist with that particular aspect, specifically for utilities, public safety, and even the state, local, and government side.
Yes. So no, I think we already spoke about.
Oh, sorry. Go ahead.
Oh, no, I know, just to be sure that we've covered. So again, it's the technology which is similar to it's what we have inside the broadband luminals here is the same technology, interoperable with some standalone products that we have as well. And at the end of the day, it's not going to be this or that. We are always going to find a way to recommend the most valuable, the most attractive mix of the standalone and the integrated solution, addressing the preferences or the priorities of the partner we work with, because we understand that it's not always one solution will fit always. Just like we know that there is room for fiber, we like fiber, but we like also to supplement with the right mix of wireless technologies, where fiber is going to be too expensive, it's going to take too much time, or just not allowed at all. With fortunately and unfortunately, lots of places that we all like and respect and want to see them continue and look the way they've been looking for the last 100 or 200 years, and we want them to continue and look so. Nobody wants to go through the pain of digging through and under, because it's just going to be too much disturbance to the traffic, the people, or the businesses operating along that street. And that's where wireless, again, in the millimeter wave spectrum, because if you go after, for Wi-Fi, it looks easy, it looks cheap, maybe, but actually that chip turns to be very costly at the end of the day when you operate some Wi-Fi network close to other Wi-Fi networks. You find that it's an unending battle to try and get it right, to a point where we've seen many partners who thought it could still be done, have to raise hands and say, no, sorry, after all, Wi-Fi won't work. Yes, there is now this new piece of spectrum, 6 gigahertz, which has been made available. But if we go back a few years, 5 gigahertz was thought to be the savior of Wi-Fi. And we all know now that if you want a reliable network, just like 5 gigahertz has not done it after a few years, 6 gigahertz will probably not do it again. It's going to be good for indoor networking where you are more in control, because it's your own premise and you know what's happening, and you are in charge and control, and you know that no other third-party network will come into play. As soon as you get out of a closed premise challenge to any kind of spectrum like Wi-Fi, will come back again. It's going to take a year, it's going to take 2 years, but the challenge will come. And on the other hand, we have been operating millimeter wave networks in the 60, 70, 80 for more than 10 years. That's what Ciclo was funded back then to do. Now we are working within Ceragon to continue and do more with the reach of Ceragon, the experience of Ceragon. We are happy to bring this technology to more applications, more partners.
Yeah, just as a closing statement, food for thought. When we're talking about redundancy, it's multiple layers within the communication side. So it can be fiber, it can be wireless. And then basically the resiliency is, building that network to make sure that there's not a single point of failure, and business continuity and essentially health and safety is going to be addressed as well. Because like I said earlier, we are seeing quite a few applications, next generation applications that are coming into play that are very concentrated on asset management, whether it be people, whether it be locations, and making sure that the critical infrastructure is not exposed to bad actors, which we're seeing more and more, whether it be on the physical side and unfortunately on the cybersecurity side as well. So food for thought, where there's a will, there's a way. Feel free to engage with us. I mean, one thing we do love about UBBA is very big collaboration within the different vendors, within the different utilities. You know, we do pride on thinking outside of the box and coming up with these, you know, these amazing solutions that basically address today's need, but also are going to be future proof as well. And essentially coming up with the next cool thing, if you will, that's going to make lives easy for a lot of utilities out there.
That was terrific, guys. Would like to remind everyone to type your questions into the question tool. Feel free to go ahead and do those. I'm going to start with the first one here. And Dimitri, you had mentioned that you know, we were going to do this session previously in the
Yes.
year. But now I think was a really good time, particularly around this first question, because talk a little bit about some of the changes from the BEAD funding. You highlighted this early and kind of wanted to come back around to some of the changes and what do they mean for utilities and technology providers now?
So BEAD funding was very heavily based upon fiber projects specifically. If we looked at the ranking system, fiber was number one. Anything wireline was top priority. Although with the current administration, it was actually communicated, I believe it was early or late last week, I was reading an article where they're starting to take an approach of being more technology agnostic and actually looking at the details of the capital project. One thing we do know, at least in my past experience, I'll give a perfect example. For everybody on the call, I'm based out here in beautiful Montreal, Canada. It gets pretty cold. We do have some mines. Funny enough, in my previous life, I was actually working on a project where they wanted to bring fiber and gigabit capacity up to a mine in northern Canada, where we were able to do a wireless project with essentially the capex on that particular project was 3.5 million versus 20 million in fiber with a much longer lead time. So essentially the US government, when they're looking at a lot of these BEAD projects, they're taking into consideration, pricing, they're taking into consideration the lead time of the project, and essentially what the evolution plan and how easy the evolution plan is to scale from essentially that particular grant. So it's not just based on fiber. I think wireless is going to get a lot more love in the future, at least with this BEAD funding from what we're seeing, just because a lot of other factors are going to be, and a lot of other aspects are going to be taken into consideration. That's a great question.
Excellent. And we've had a couple of questions come in, so I want to go ahead and get on with the next one while we have time. What is the rough size of the base station that goes into the luminaire, and does it use an internal antenna? And I might have a follow-up on that one. Is it embedded base station, a generic product, or is it only available as part of the luminaire? Hopefully I read that all correctly. You want to speak a little bit about that?
Yeah, so good job, Bobby, first, and whoever was asking the questions also, thank you. The same technology is available in the standalone product or in a very special form factor, which is which is flexible enough so that it can be inserted in a lot of luminars. I will not say right away in all luminars, but so far we have not seen any limitations. The luminar is going to be from under the luminar the same size. We don't need more real estate. If you look at it from the side, you'll see that it's taller because we put the radio basically on top with a special cover so that visually it would look like a traditional luminar. If you have a NEMA sock, if a NEMA puck on top, the NEMA puck will still sit on the top to control the lighting itself, in any way it was being controlled before, so we are not changing that part of the lighting operation. We are just adding the broadband communication on top of it. And it's small enough that, again, any kind of even the most modern luminar, the smallest one that we've seen so far, we have not seen any problem. We put actually a total of 4 antennas on top of that luminar to cover 360 degrees, so that the mesh that is deployed is going to really cover, 360 degrees, and then again 360 degrees, and again until you cover all of the service area and all what you need to connect.
Excellent. And a kind of a follow-on probably, or a related, I think, question to that is, and I know usually when we talk about cost, there's a whole lot of it depends, but the question specifically says, would you be able to please give some idea of the relative cost of this solution? And I'm assuming they're speaking of the Luminaire solution.
Okay, so I would say from no. So obviously it depends, but everybody, if you look at the cost of a wireless network deployed on a luminar compared to the cost of swapping a luminar to a broadband luminar, you will see that you are very much in the same numbers. Okay, which is difficult to believe, but there is actually, if you go to an integrator and you ask them, please put me this Cyclo by Ceragon technology on a luminar, they are going to quote you a number which is not very well connected to the cost of the product itself, and you can go and have some good ideas of the cost of our products. Also, if they give you like a total number for the radio deployed operating on the luminar, you will see that it's more, sometimes significantly more, because they are just the radio and the power and the labor and the design and a lot of things basically that comes into the time that they are going to spend, which is not going to be the 20 minutes or less. Plus, they now need to send a wireless engineer to put this radio on top of a luminar and activate it and configure it, etc. Whereas here you just put a luminar, 20 minutes in and out. You have most of the time the utility has the team in-house to do it. They don't need to hire another contractor to do it. So when you look at these two together, side by side, you will see that very often you are close, but you need to account for all what it takes to get a radio working on top of a luminar.
And just to add to that as well, because we didn't even touch, Shimon, we didn't even touch on the actual light system itself, which is eligible for quite a few subsidies and grants. So big picture, it's actually quite inexpensive, but it really all depends. And I hate giving that answer, but I don't think we could avoid that answer, to be brutally honest, because it really all depends on where it is, how it's getting deployed, and basically the magnitude. But I mean, if you're looking at the total cost of ownership, as Shimon said, if we're looking at an actual deployment of, for instance, a wireless technology on a light pole compared to swapping out just the luminaire, it's more or less that part.
Yeah, excellent. Well, thank you for your openness about that. We will follow up with the other questions by email, because we're really at the top of the hour. And I just wanted to give any final comments, Dimitri or Shimon, that any nuggets you wanted to leave the audience with before we close?
I would say that, very exciting to see that finally regulators and the administration, the government is putting a lot of emphasis on the critical infrastructure portion of the utilities. And hopefully, at least with the other regulators, are gonna take notice and start adopting quite a bit of that particular mentality. But but I'm very excited moving forward, at least for the utility vertical, is, you know, getting them up to, getting everybody up to speed and assisting through the journey of this digital evolution.
Excellent. Wonderful. Well, we will close with that final word then. I will again thank the Ceragon team for bringing this knowledge to the UVBA audience and to everyone. And I'll remind everyone on the call that the Ceragon team will be at the UVBA Summit and Plugfest in November, and you can certainly continue the conversation there. If you want to register, we would love that. Go out to uvbaplugfest.org, check out the agenda, register, book your hotel room, all that good fun stuff. And again, thank you all so much for being part of the webinar today. Knowledge sharing is a big mission for UVBA, and this is a wonderful opportunity to do that. So Shimon and Dimitri, thank you again so much. And for everyone, stay safe out there, and we will speak with you again soon. Thanks, everybody.
Thank you.
Thank you. Bye-bye.